Hello everyone, Dr. Hassan is here with another lecture of Physics 120. So before listening to this lecture, I'd like you to know the meaning of density. Density meaning that how heavy something is with respect to its volume. Like we know water is heavier than oil, and then you can say iron is heavier than water. Again, before you starting this lecture, I'd like you to go and listen to those lectures on density. So today's lecture is about fluid statics related to pressure. We all know that if you go under a pool, so if you go on a pool of water, you can actually feel more pressure. So assuming that there's water, you go underneath of a pool, then here you can actually see lots of pressure. So pressure is an outcome of what we have here, the column of water. Like the more you go down in the water, you are actually facing more pressure. So now what is pressure? Pressure is feeling of compression or tension, and then as the area goes down, pressure goes up. You already know that. So assuming that, because again, pressure is force divided by area. That's actually the definition of pressure. Now, when we apply pressure into subject, we can say, okay, if this is an object and I apply pressure like this. Now, pressure is actually the force that we apply divided by area. So in this case, this will be the cross-sectional area. Now, if you get a popsicle stick and you push it on your hand, you can feel some specific amount of pressure. But assuming that if you use a needle and then you apply the same force, you can actually see lots of pressure. It actually can go through your body. Now, the reason is that because the area is very small. So we are talking about very small area. Now, when the area is very small, the total pressure will go up. Now, what was the unit for force? The unit for force was Newton. The unit for area is meter square. Now, pressure, the unit for pressure will be Newton per meter square. Now, Newton per meter square is also called Pascal. We show it with P, PA, and this is actually called Pascal. In this case, now if you look into inside the water, you can see pressure, and the pressure is applied to all over the object. Like if you put a ball on the water, you can see pressure is applied to all surface area of this ball. This is actually pressure in a fluid. So before I go pressure in a fluid, I'd like to talk a little bit about pressure, about the units of it, how we do the calculation for pressure. We already know that pressure is equal to force over area. So when we say force over area, we already talk about that the unit for force is Newton. The unit for area is meter square. So your final unit will be Newton per meter square, that we simply call it Pascal. But pressure has all other units. Like pressure in your car, not your car, in the tire of your car, called PSI. Now, when you going to inflate your tire, you inflate the tire for like 30 PSI. Now, what is 30 PSI? In the case of PSI, we use, so PSI is called pound per square inch. So you can say pound per square inch. Now there are unit conversion. You can actually convert PSI to Pascal. We are not much interested on that, but just to giving you an idea of like when you say 30 PSI is equal to 2 bar. But what is bar or atmospheric pressure? So bar or atmospheric pressure is the pressure that we are actually living on. Now the pressure that we're living on in terms of Pascal is almost equal to 10 to the power of 5 Pascal. So we are living under a pressure of 10 to the power of 6 Pascal. So we are living in 100,000 PSI. So 100,000 PSI, meaning that if we assume our body is 1 meter square, the amount of force in our body, which is from the column of air, so again, bar is, we call it atmospheric pressure. So we are living under 100,000 I put PSI, my bad, Pascal I meant. Pascal. 100,000 Pascal, and then that 100,000 Pascal, if you assume that your body is 1 meter square, you are under pressure of 10,000 Newton. And 10,000 Newton translate into around 1,000 kilogram, meaning that in the surface of Earth, we are enduring 1,000 kilogram of force. We don't feel it, 1,000 kilogram of force. We don't feel it, but it's there because we were built in this pressure. Now, the next one is the pressure in the fluid. The pressure in the fluid is you go down the pressure in the fluid, you can say pressure is equal to density of the fluid times G times the H. So density of the fluid, like for instance for water, density is around 1,000 kilogram per meter cubic. The G is 9.8 and then H is the height. Now, as you go more down, or if the height of water is higher, you can actually feel more pressure. So the pressure is actually equal to dGH. This is the equation that we use for pressure in the fluid. Now, depending on two things, one is D, which is density, and then the other one, H, is the height, assuming that we are in the earth, right? It just depends on these two factors. If you go under another fluid, which is lighter, you can feel less pressure, but if the fluid is heavier, you can actually feel more pressure. Something like if you go into a pool of honey, you can actually feel lots of pressure, but if it's oil, you can feel less pressure. The next one is about Pascal's principle. What is Pascal's principle? Pascal's say that if you apply change in pressure at any point of the confined liquid, an equal change will occur in the other side. So what does this mean? Let me just to show you a picture. This picture is very much familiar with you. Now, this is the jack that you use to lift the car. Now, when we lift the car, we use our arm. Our arm doesn't have a lot of force. Like mostly you can apply 100 Newton. But how heavy the car is? The car is more than like 10,000 Newton. How can you apply 100 to 10,000? Now, in this case, what you do is that we know the Pascal's law is talking about if you apply the same pressure in any point, the pressure will be the same, right? So the pressure here, PA, will be the same as PB here. Now, how they play a role? If the pressure here is the same as pressure there, then I can say the force A divided by area A would be equal to force B divided by area B. That's actually came to this equation. Now, force A divided by area A is equal to force B divided by area at B. Again, the area at A is this much, area at B is bigger. Now, when you apply a small area here, small area, small force, create a decent pressure. Now, in the other side, because you have a bigger force, you have used a bigger area. Now, what is the issue? How we got a free ride? There is no free ride, as I said. The problem is that in this side, once you apply pressure, you go this much down. But in the other side, you go a little up. Because the area is too much big, the fluid cannot move that much. So now, in order for you, if you apply 100 Newton, and then you want to raise a 10,000 Newton of car, you have to do it 100 times. So you have to take the pedal, and then you have to raise the pedal up and down here 100 times, just to go this one time up, right? If you want to bring this one 1 meter up, in the other side, you have to apply 100 times. That's where we can actually, we are losing our time. We do it a lot with the time. Now, but again, we are unable to raise the car like that. But now, the next slide, I just want to do an example. What's the mechanical advantage of hydraulic press that pushes with the radius of 0.2 and then which lift 0.4? So let's look at here, this case. So you have a 0.2 in one side. You have 0.2 in one side. No, it stopped writing. So I have 0.2 in one side. Okay, with 0.2 in one side, 0.4 in the other side. Now, this is the radius. Remember, mechanical advantage was always related to the load divided by the effort. In this case, because you don't remember that when we say AB over AA, this is actually, we mean force A over force B, the opposite way. Now, mechanical advantage for most of machines are more than one. In this case, that's why you put the higher area over the smaller area. We use area, we don't use radius, because you already know that area of a circle is equal to pi r square. Okay, so next problem. A 5 kilogram weight is applied to a piston with area of this much, and at the bottom of the tank, what is the pressure change due to the weight? Now in this case, we use delta P, which is going to be force over area. The force of 5 kilogram weight, which would be 5 times 9.81, the area is 1 meter, then the answer is going to be 50 Pascal. So, but let's talk about buoyancy force. What does buoyancy is? Buoyancy is about a force that when you put something inside a fluid, inside water, you feel them less heavier, right? So that's because they become a buoyant force. A buoyant force is a force that actually created then pushed the stuff up. That's and then that's actually due to the I can say more into is doing with the weight of the object that we have. You can actually prove based on the equation that we have, if you have F1 there, F1 up here with the weight of the body, you can prove that the buoyancy force is equal to density of fluid, volume of object under the water, right? This is actually has to be underwater times G. The first guy who came with this idea was Alec Middles, and Alec Middles actually, so if we talk about his law, again in a second we go to his law, but that was what he came with. Now in this case, if something is floating, buoyancy force is equal to weight of the object. Yeah, it completely makes sense because you are all the way up there. Now if you are floating, meaning that you are here. Now in equilibrium there are two forces, right? One is the force of the weight of this guy, and then which is mg. The other force is the buoyancy force. We call it F of buoyancy, Fp. These two has to be equal so that you are in equilibrium and then the object is floating. If it's sinking, buoyancy force is less than the weight of the object. That kind of makes sense. And then buoyancy force is density times G times the volume underwater. Again, density is the density of the fluid, it's not density of the object. Remember, in the density is the density of fluid. Volume is the volume of object which is submerged underwater or under fluid. G is the gravity. Now, what is Alec Middles Law? Alec Middles Law is the principle is that there is a legend that he was working on the gold and he came out naked. He said, I found it. But what was his idea? His idea was that when you actually put something under the water is lighter. Once you bring it off the water, it becomes heavier. And then how much it become heavier and how much it become lighter? The amount that this object become heavier, that's actually, again, let's get the case like this. You have water inside this, right? When the water is inside this, and then just play with something, right? You have a very heavy object here, like assume that you have aluminum in your hand. Then you connect it to a rope. As long as this aluminum is underwater, it's easy to take it off. But once you get to the air, it becomes more difficult, it becomes heavier. Because once you bring it to the air, the amount of force that you apply is the same as the weight of this aluminum. Now, as long as you are in the water, the amount of force is much less. So that's the talk of Alec Middles Law. So let me just do a recap of what we taught. The first one was pressure is equal to force divided by area. The second one, pressure in the fluid increases with the depth of the fluid or the height, which is D is the density, G is the gravity, and H is the height. And the Pascal's Principle or the buoyancy force, again, Pascal's Principle was that the pressure is happening and all the points are the same. Same example of the car, you apply in one point, you can get the force in the other location. The same amount of pressure. And the last one is about buoyancy or buoyant force, which is equal to the weight of the water displaced or the weight of the fluid displaced, I can say. Maybe it's not water, it's something else. Okay, thank you very much for listening to this video, and I wish you a great time.